Welcome back to the video lecture series for Introduction to the Art of Scala, or Introduction to the Art of Programming using Scala. Our last example for direct access binary files is going to be making a linked list inside of a file. So the previous videos we have basically been making standard sequences, and the way that we treated them was very much like an array. The values in the file were consecutive, and we would have had the standard problems that we have with arrays, in that inserting and removing from the middle is inefficient. So what about, and it would actually be particularly inefficient in the file because of moving all the values around in the file would be very expensive. So the advantage of a linked list is that we can move values around, insert and remove, without actually moving things, because we just insert nodes or remove nodes. So what I want us to do now is to write a class that represents a linked list that will be stored inside of a file. And we're going to keep things nice and simple. We're going to use a fixed length record. So we'll go ahead and we'll make a Scala class. We'll call it file linked list. It's going to take a type parameter of A. And what do we want to extend here? Previously we extended index sequence, but the advantage of the linked list is the ability to insert and remove in various places, and so perhaps a better option would be the buffer type. This is what we did for our previous linked lists. The downside of doing the buffer type is there are a lot of methods in here that we will be writing. So, but oh well, that's what we're going to work with. So we'll extend collection.mutable.buffer, and if we copy all of this, we can start adding all of our methods. Okay. Oops. Okay. When we create this, we're going to have to give it a file to build off of. We'll pass in a file name as a string, and as before, we're going to create a new random access file that has the capabilities of reading and writing. And now we need to think a little bit more about what goes inside of this file. Okay, so if we were building a regular linked list, the structure of our linked list was to have a node, and that node would store the data, and then at the least a next pointer, possibly a next and a previous, depending upon whether it was singly linked or doubly linked. We found that doing a doubly linked list with a sentinel was kind of an ideal way to do things, and I would argue that that's kind of what we should model in this example. So our file is going to have a whole bunch of records that have not only the type A, but they also have a next and a previous. So the record format could be previous, next, and the value A, where previous and next are, instead of references as they would normally be, they are ints, okay, so that they kind of point to other locations, other nodes inside of the file, and we can calculate an offset based upon that integer index. In addition to that, we need some type of header information here. And the idea is when we delete a node, when we remove something from our list, we're going to basically free up a node inside of the file. That node should not be permanently lost. And so for my header, I kind of want to put at the beginning of this file the value of the first thing that's free inside of the file. That is also going to be just an integer, and so the format of our file is going to be this integer and then these two integers followed by an A repeated over and over again as many times as we have allocated nodes inside of this file. The first free is going to reference the first node that's free, and then we can use either previous or next inside of that to reference the next thing that's free and the next thing that's free and the next thing that's free. So that basically we're creating a singly linked list of all of the nodes that haven't been used yet. As was the case with our other linked list, it might also be nice to store the number of elements and that will, well, I put 0 there, but we might have to come back and visit that. And indeed, that should be stored in our header as well, so that when we open a file, because one of the things that wasn't really addressed in the previous examples is the fact that you could create one of these objects and give it a file that already exists, and it should work from that. And our previous examples would have worked from that. They didn't need any additional handling because they kind of didn't have this header information. In this case, because we have this header information, we're going to need to do something a little bit different. I'm writing these right now as 0 and 1, but in reality, if we created a file that already existed, then those values are written there and we should read them. So the way this should really work is if ref.length equals 0, that's an E, not an A, then we return that. Else, I want to return the tuple of raf.readInt, raf.readInt. So we'll read the first two integers, which are the two header values, and then everything else will go fine from there. So I'm going to stop this video here, and we'll come back in the next video, and we'll continue working on our file-based linked list.